All right, guys, welcome back. So today we are going over less pressure on what we've learned in the past. So let's get started with that. So we're gonna sketch a graph to represent the situation and then label each section. So the level of water in a river rose rapidly during the storm and then gradually decreased back to the original level. So remember, when we get these types of problems, you first want to identify what your two variables are going to be. So because if we're going to graph it, we have to draw kind of like a nice little graph. We've got our x-axis and we've got our y-axis. Now remember, each of those axes are going to be variables. So I see the level of water is what's changing, right? So that's definitely going to be an axis. So I'm going to put the level of water to be the y-axis. Okay. Now, it doesn't really say what the x-axis should be necessarily, but we know that if a storm is passing by, the x-axis is going to be time, because over time, then the storm will pass by. So we're going to make the x-axis time. Time is actually a very good one. If you're not sure what the x-axis should be, that's a lot of the time what it's going to be, okay? So if the level of water as the storm is happening, it's obviously increasing, right? So it's going up in the beginning. And then as the storm dies down, it says it gradually decreases back to the original level. So it's gonna stop, the storm's gonna stop, the level will stay the same, and then it's gonna go down over time. And it's gonna go all the way back to the original level, okay? The level of the water. Now, if you made your graph from here doing the same thing, that's fine, as long as you had a graph that went increased, was steady at some point, and then decreased at some point as well. So this would have been an acceptable graph. Make sure, guys, that you are labeling your x and your y-axis. That is super important. If you don't do that, there will be points off on an assessment, okay? In 4.4, graphing a function rule, I've got a nice little warm-up as a refresh. So again, this is lesson 4.4, graphing a function rule. Let's go ahead and put our names and let's get started. Okay, so our objective here is to graph equations that represent functions. So we've talked about functions, we've talked about linear functions, we've talked a little bit about nonlinear functions, and we know that functions have a pattern, linear functions have a pattern. So what we're gonna do is just explore how to graph those using a method that I like to call plug and chug, okay? So, let's see. Oh, that link doesn't work. Okay, well anyways, so we're gonna graph a function rule. I want you guys to put that this rule that we're gonna use is called plug and chug, okay? Because once we are given the equation, so we're finding the graph of the function y equals negative 2x plus 1. We're just gonna plug in values for x, and we're gonna see what the y values will be, okay? So we're gonna plug in for x negative 1, because that's our first value in our table. So wherever we see x, we're gonna put negative 1. So y equals negative 2x plus 1 is gonna become y equals negative 2. We plug in the negative 1. Remember, whenever we're plugging in for a variable, it always needs to have parentheses, plus 1, okay? Now, negative 2 times negative 1, and then we're gonna add 1. So this would be positive 2 plus 1, which is just 3, okay? So for our coordinate, our x was negative 1, and our y became 3, okay? So we can go ahead and fill in all of the coordinates with what the x coordinates are, right? So this one, the x coordinate's gonna be 0, so we're gonna plug that in. 1, and then 2. All right, so let's try some more. So we're gonna plug in 0 and see what we get for y. So y equals negative 2, remember those parentheses, those are super important, times 0 plus 1. Negative 2 times 0 is gonna give us 0, and then we're just gonna add 1 to that and we'll get 1. So our next coordinate is 0, 1, because that was our y coordinate, or y portion of the coordinate. Next, we're going to have at x equals 1. What's y going to be? So this is going to be negative 2 times 1 plus 1. So negative 2 times 1 is negative 2 plus 1. Negative 2 plus 1 is just going to give us negative 1. So it's 1, negative 1. And lastly, let's use 2. So this is going to be negative 2 times 2 plus 1. Negative 2 times 2 is going to give us negative 4. We add 1 to that, and we're going to get negative 3. Okay? All right, so from this point, now we are going to go ahead and graph it. So on our little piece of graph paper here, we're going to go ahead and label our, let me do that a little bit thicker so we can all see it. There we go. This will be our y-axis. And this, doesn't matter where you put it, will be our x-axis. Okay? And now we're going to go ahead and plot each of these points. So the first point that we're going to plot is the negative 1, 3. So here's negative 1, and then we're going to go up 1, 2, 3. Remember, your x coordinate or your first coordinate is always how much you're moving horizontally, and then this one's always how much you're moving vertically. So we're moving to the left 1 because it was negative 1, and then up 3. So this is our point. And we're going to also label it negative 1, 3. Our next point is going to be 0, 1. So we're going to move to the left or right 0, and then we're going to move up 1 unit. So we're going to move to the left or right 0, so we're going to stay at the origin, and then we're only moving up 1. So this point is 0, 1. All right, next point, we're going to move to the right 1, and then we're going to move down 1. So this is 1 and then negative 1. So this is going to be our point, 1, negative 1. And lastly, we are going to plot the point 2, negative 3. So we're going to move over 2 units, and then we're going to move down 1, 2, 3 in the y direction or vertically. So this line is our graph. Okay? And as you notice, it is a straight line, even though I kind of messed up and I drew it a little squiggly. It should be a straight line. And the reason it's a straight line is because, look, it's a linear function. It has a pattern, okay? It's going to be y equals mx plus b, right? Whenever we have a function in the form y equals mx plus b, we know it's going to be a linear function, okay? In this case, our m is the negative 2, and our b is the 1, okay? Those are the types of functions we will be graphing, all right? Okay, let's do one more example just to make sure we understand, okay? So we're going to graph the function again, and remember, we're going to use the plug and chug method. Okay. So it's asking, what is the graph of the function with the rule y equals 1/2 x minus 1? Now, off the bat, guys, is this in the form y equals mx plus b? Absolutely. So we know it's going to be a linear function. This 1/2 is our m, and then this minus 1 is our b, okay? So we already know that it's going to be linear, so we know it's going to be a straight line. And now it's just a matter of plugging in values and then chugging to see what they're equal to. Okay, so we're going to use the chart, and we're going to plug in x as negative 2. When we do that, we get y equals 1/2 times negative 2. Remember, always put parentheses whenever you're plugging in for a variable, minus 1. This will give us, what's negative 2 times 1/2? That's just going to be negative 1 minus 1 equals negative 2. So our coordinate is negative 2, negative 2, because x was negative 2 and y was negative 2, okay? Next one, we're going to plug in for x equals 0. So y is going to be 1/2 times 0 minus 1. 1/2 times 0 is just going to give us 0 minus 1 equals negative 1. So we're going to get the point 0, comma, negative 1. Our next point is going to be x equals 2. What's y going to be? So we're going to get 1 over 2 times 2 minus 1. 1/2 times 2 is the same as 2 divided by 2, which is just going to give us 1 minus 1, which is 0. So we get 2, comma, 0. Our x value is 2, and our y value then became 0. Next one, we've got 1 over 2 times, now x is going to be equal to 4 minus 1 equals, okay, so now we've got 1/2 times 4 is the same as 4 divided by 2, which is going to be 2 minus 1, which is just positive 1. So now we've got 4, comma, 1. Okay? All right. Now, as soon as we've got all of our points, we're going to go ahead and plot them. So I'm going to use the red again. I'm going to make it a little bit thicker so we can all see it. Here's our y-axis. Draw that line straight down. Beautiful. This will be our y, and then our x-axis will be right here. Perfect. X-axis. Oops. Let me put it over here. X. Okay, so now at this point, what we are going to do is we're going to go ahead and plot all of our points. So this is the easy part. This is the chug part, okay? So we've got negative 1, negative 2, negative 1, negative 2. At negative 2, negative 2, that's 2 units to the left and then 2 units down. That's going to be right here. Or when x is negative 2 and when y is negative 2. This is negative 2, negative 2. Okay, our next point is going to be 0, negative 1. So we're not moving in the x direction at all. We're only going to move in the y direction, down 1. This will be this point right here. 0, comma, negative 1. Our next point is going to be 2. So to the right, 1, 2, and then up 0. So at this point, this is called 2, comma, 0. And then, let me move that, sorry. 2, comma, 0. And then our last point is going to be at 4, 1. So this is going to be 3, 4, and then up 1 in the y direction. This will be 4, comma, 1. We draw a line through all of these points. It is straight, and we are good to go. Okay, you can also double check. Remember, B is your y-intercept, right? And our y-intercept should have been minus 1. Does our graph cross the y-axis at negative 1? It sure does. That's this point right here. Beautiful. Okay? All right. We're going to do one more example, and that's the end of the lesson for today. Okay. So we've got problem number 2, real world problem. So the function rule W equals 8g plus 700 represents the total weight W in pounds of a spa that contains g gallons of water. What is a reasonable graph of the function rule given that the capacity of the spa is 250 gallons? Okay, so just like we did in the previous problems, this one doesn't give us a chart, so we're going to make our own chart. So we're going to have values. G is now our x, and W is now our y, right? So we're going to have our values of G. We're going to plug those into W equals 8G plus 700. And then we're going to get a coordinate G, comma, W. Okay. All right, so it says that the capacity of the spa is 250 gallons. So we're not going to make G go over 250. So 250 will be our last value, 250. And I recommend that we do G equals 0, 100, and 200, and then 250. Okay? So for these values, let's go ahead and plug them in. So what is W when G is 0? So W equals 8 times 0 plus 700. Well, 8 times 0 is 0, so this is just going to be 700, okay? So our G comma W is going to be 0 comma 700, okay? Let's do the next one. So 100, W equals 8 times 100 plus 700, oops, equals 8 times 100 is 800 plus 700, that's going to give us 1,500. So our G was 100 and our W was 1,500. Next, we've got 200. So W equals 8 times 200 plus 700 equals 8 times 200 is 1,600. And then we are going to, we're going to add 700 to that. What we get here is 2,300. And that is going to be 200 comma 2,300. Remember, your G is always your first part of your coordinate, first portion of your coordinate, and then your W will be your second part, just like X and Y were, okay? So now we've got W equals 8 times, instead of 200, it's 250 now, plus 700. 8 times 250 is, is 2,000. So 2,000 plus 700 is going to give us 2,700. So we've got 250 and 2,700, okay? Now, that was pretty easy. That was just plugging in values and then figuring out what the W values were going to be, okay? Now, the tricky part is coming up with a graph so we can graph these super large numbers, okay? But it's not as complicated as it seems, okay? So what we're gonna do is we're gonna do exactly how we used to. We're gonna draw a vertical line to represent our horizontal axis and a horizontal line to represent our horizontal axis, okay? Now, it's not X and Y, right? We've got G and W. So remember, your first variable in the coordinate is going to be G. So we're gonna label this axis G and this one W, okay? So now any value for G, we're gonna plug in and then we're gonna get a corresponding W value. Now, what we increment by is gonna be super important. So in the G direction, okay, I want to increment, we go from 0 to 100 to 200 to 250. So I'm gonna go by 50s. So 0, here's 50, here's 100, here's 150, here's 200, and then here's 250, okay? That way we can plot it really nice, okay? And then in the W direction, we go from 700 to 1,500 to 2,300 to 2,700. I'm gonna go by increments of, let's say, 500. So 500, 1,000, 1,500, 2,000, 2,500, and then 3,000. Okay? Remember, guys, you guys can increment by whatever you want. Now, if you wanted to start at 700 on your y-axis, remember, you would need, or your w-axis, you would need a break in there, okay? But in this case, I'm not using a break because I'm starting at 0 and I'm going to 500, and we're increasing by 500 each time, okay? All right, so let's take a look. What happens when G is 0? What's W at? It's at 700. So if we were to plot that, that's going to be above 500 but below 1,000, so somewhere in here. Okay, so that's our first point. Our second point is at 100 in G, so that's going to be the second increment, and then it's going to be 1,500. So it's going to be right on our, right where they cross. So at 100 and then 1,500. Next one, we've got 200 and then 2,300. So we've got 200, so that's all the way over here, and then 2,300. So let's go over to 200. 2,300 is in between 2,500, a little bit more towards the 2,500. That's right here. And then our last value is 250 for G. That's right here. And then we're going all the way up to 2,700. So if we go all the way up to 2,700, that's going to be in between 3,000 and 2,500, closer to the 2,500. And if we were to draw a line through all of these, absolutely, it's a straight line. And we knew that going into it because look, W equals 8G plus 700. Is that in the form Y equals MX plus B? Absolutely. Except our Y is now W and our X is now G. Okay? But that stuff really doesn't matter. Okay. These are the 3 questions I want you guys to do. Check yourself. Okay? I want you guys to do those problems. Remember, plug and chug for each of them. Here are the answers. Go ahead and check yourself. Okay? And then here's your homework. Good luck. Let me know if you have any questions.